Hello, everyone. Give me a thumbs up if you can hear me. Welcome to Community Conversations for Technomatics. Awesome. I see the thumbs up. I'm Taryn Blake, Community Engagement Program Manager for our Siemens software community, and I'll be your host for this enablement session. Today's topic, as you can see, is Fluid Library Basics, and we are here with our usual guest speaker. Most of you probably know Mr. Stefan Bongso. He's a freelance simulation expert. Definitely, he's been doing this for quite some time with 5 books on plant simulation, and he is definitely working on a 6th book as well. He's one of our leading contributors to the Siemens PLM community, and he is a community catalyst for us here at Siemens PLM. So today, he's going to go through 4 big steps. You'll see, so application fields, fluid, source, material table, pipes, tank, and mixer, and then deportioner and portioner. So looking at these 4 areas for the Fluid Library Basics. And then, of course, like we said, we are live this week, as every week, absolutely live. So if you can't hold your question, type it in the chat, and then at the end, you guys can come off mute and ask questions. So that's it for my introduction. Stefan, feel free to steal the screen.
Hello again for a new webinar. Today I want to show some basic stuff with the Fluid Library. I guess many of you have seen this already in your class library. And I want to create 2 small models today to show, okay, how is the basic handling of the Fluid Library. And in the second small example, we will start programming using the Fluid Library. You see there are some elements. I'm using for today the version 2504 because I want to show you one example with the continuous mixer. This is new in 2504. And as a first example, I want to show you a small juice production, juice from concentrate. What's the difference between the material flow elements and the fluid elements? The fluid elements you need to connect with pipes. For instance, if I want to model production of juice from concentrate, I need to first define some elements in a so-called materials table. You need to switch off the inheritance. In this table, we define materials and the colors of the materials, some additional attributes like density, the unit we want to use, a kilogram or liter, and then we can create recipes. So first I want to define 3 different materials. I want to start here instead of standard material. I want to have a concentrate. I can select a color here, maybe red. Product amount is liter, or the unit is product amount is 1, and unit is liter. If you use American standards, then you may have different units here. Second one is I need water. Density may be also 1 gram per cubic centimeter or 1 kilogram per liter. The color should be blue. Product amount is also 1, and unit liter. And then I need to define the final product. This is juice. also 1 liter per 1 gram per cubic decimeter, and color should be red. Product amount is also 1 liter. And here I need to define my recipe. The first ingredient should be concentrate. Amount 0.1 liter. And the second is water. Amount is 0.9 liter. And this will lead to 1 liter juice. And so you can define up to 10 ingredients here for a recipe. And you can define also more products here in one table, and a lot of different materials. And so you can use one table for several models if you place this table into the class library. I have 2 different examples here, and so I want to use 2 different materials table. Okay, this is one of the difference between the other elements. Here you need to define your stuff into this materials table. So now I want to create a really simple model. I need fluid sources, 1 fluid source and a second fluid source. And this fluid source is for concentrate and 1 for water. And I need 1 element. It's the continuous mixer here. It's a quite small element. This will mix these 2 materials together and will result in our juice. And to connect, I need to use pipes. And you'll find this here. You can snap the pipe here. And I need another pipe from the second source. You need to connect the elements like the other elements in plant simulation with connectors. To determine the material flow. We need to make some settings. For the continuous mixer, we need to transport the materials in the right ratio, and so we need to set here the right outflow rate. Maybe this is the flow rate for concentrate. It's 0.1 liter per second. Materials selection is constant, and the material is juice, is concentrate. And I need to define the materials table. It's not the materials table from the class library. It's a materials table from my frame here, and so I need to correct this. I can create shift calendars and so on, and you can define failures. And you see it's not so many tabs like in the other material flow elements. No setup, no exit behavior, and so on. Okay, the second source, we need to define the outflow rate for water is 0.9 constant. We have water. And we need to use the materials flow materials table from the frame. Okay. So the next element I want to show is the portioner. You see the connection to the pipe is here. So I need to turn it around. Okay, it doesn't work. Okay. Wait. So I need again a pipe from here, there. Okay. And I connect this with the continuous mixer. And here I need a connector between the pipe and I need the portioner, not the deportioner. The portioner will create MUs from fluids. For instance, if you have a filling line and you fill up bottles here, then you can use the portioner to fill a certain amount of liquid into a bottle, and then after this, the bottle runs through the simulation as a MU, as a movable unit. So to see what we create, I take a conveyor and then, okay. I need to do a setting here in the continuous mixer. The continuous mixer needs to, here we need to define what kind of product we want to create. Let's choose. And again, we need the right materials table. Yes, and then I need a bottle. So I take MU here, take the part, duplicate the part, and name it bottle. And this we need to create here in this portioner. We need to define what kind of MU I want to create. I want to create bottles. And we need to define how many of the predecessor fluid we want to use to create one bottle. It's 1 liter, for instance. And we need to define from which predecessor I get the fluid. And it's easy, it's only one here. And that's it. So, and then we can already start this model. You see, okay, the pipes are colored with the material colors. And if you point the mouse to the pipe, you see, okay, it's fluid source concentrate connected with the continuous mixer. And the colors you can see here in this table, yellow is juice, concentrate is red, and water is blue. And so you can see, okay, what's inside the pipes. And from this on, from the portioner up, after the portioner, it's a normal MU, and then comes all the steps you can simulate packing or closing the bottles and labeling, packing, and so on. That's the next step in such a line. Okay, this is the first very simple model I wanted to show you. And the second one, you can also model bulk materials. For instance, if you have injection molding machines and you want to show, okay, we need a worker to fill up the bunker of the machine with granules, then you can create this injection molding machine also with the elements from the fluid library. And here we need to program a little bit to get the right behavior. And so I make a second model. Okay, we have already some elements from the fluids library. We had a fluid source, fluid train. We can also have, I'll show it in the next webinar. And for changing from a mu to fluid, we can use the deportioner. So I need a deportioner. So the storage of the machine, I can simulate or model with the tank. And the injection molding machine, I can model again with the deportioner. So these three elements, and these three elements I need to connect with pipes. I turn it in the right direction. You can see the connection to the pipes here. So this I connect with pipes. Okay, it's a little bit too long. It's the same like the track. You have to press M on your keyboard, then you get some anchor points on the pipe, and then you can change the length of the pipe with the mouse just by tracking, and then you can connect it in the right way. So I need a second pipe from here to here, and we need to connect it with connectors. What's wrong? Don't see it. And here to here. Okay. I need a portioner, not a deportioner. The portioner, not the deportioner here. And so connect all this together. So. Okay, what's missing here? I need a connection between the source who is create the granules for my injection molding machine, and this is a normal MU. So I need a source. And I want to use the worker to fill the tank of the machine. And so I need some workplaces. One workplace here. I activate the transport importer. Second one here. At the deportioner, I don't need additional importer. I duplicate this part and name it Granules. And I create this here in this source. Okay, I need to define in the deportioner how many, what's the amount of material I get here. The amount per MU is here, for instance, 50 liters. And here I need also a fluids table. No way to skip this step. So I need a materials table here. And I need to define my material I have here. Okay, it's fixed. And so I need to define my material. So in this case, we need to use the same name as the MU that we delayed here through the deportioner and create the fluid. And then we need to do some settings here in the tank. We need to set the volume of the tank. It's also 50 liters. And we can define the outflow rate. We can let it at 1 liter per second or make it a little smaller, 0.2. Okay, and then we need to set the portioner. And again, I connected portioner with a conveyor to see what we create. And one tray. So starting from the start again, we have a source. The source creates granules. Here in the deportioner, we need to define outflow rate, how fast the material is flowing out of this element. And we need to define how many granules contains 1 MU, it's 50 liters. And we need to define the materials table. Again, it's here. And here we need to define the material. Not more here in this example. The tank. For the tank, we need to define the volume. How big is the tank here? And we need to define an outflow rate. And the outflow rate and the amount of material here in this MU, this determines the time it needs to fill one of this element. So I have an outflow rate of 0.2 meters liter per second and a volume of 50 liter in the tank. And here we need to define how many material contains 1 MU, maybe 0.5. So it takes time if the outflow rate of the tank is 0.2 to fill this MU. And then we can define some recovery time that is needed after, for instance, for a little cooling, maybe 10 seconds. And setup time is for each part. We can also define that setup time. Okay, these are the settings I need for these elements. So the MU, I want to create its MU's part. I don't want to have another one. And now I need a little control here because I need only to bring another package of granules to this deportioner if my tank is almost empty. And then I fill this tank up to the 50 liters. And so I need a little bit programming here. So we need for this, for the worker, I need a worker pool, I need a broker. And then please check that here in the source, the transport importer is active. So to avoid to transport continuously parts to the deportioner, I use here a little trick. In the source, I create an exit control, F4. And this exit control is completely empty. So I need to trigger the movement of the granules here to the deportioner from outside. And the first movement I can trigger by the init method. So I create a method into my frame. I rename it to init. And we could check my cheats here, cheats. Okay. And we need some other tricks here to change the tank load. I need to lock the exit first of the tank. And it's the same like for the other blocks, it's exit locked. Then I need to wait until the source is occupied. And then I just trigger the movement with source cont move. And this will call the worker then. Okay, this here, this I want to check. Okay, I need to set a destination. So I connect this just two elements. Otherwise, there's a destination missing here. So here comes my worker, takes it apart. Okay, the product name was not found. Okay, my source need to create granules. Okay, granules. Granules. Okay, it's here. I need to define granules also here. Sorry. And then it should work. Worker comes, takes the package, and then you see how the tank is filling up. And if I start, so now you can see the other pipe is okay. It's not okay. It should be connected. So, but my exit is locked here, and I need to unlock the exit if I reached the capacity of the tank. And for this, you can define some sensors here in the tank. I want to have two. The first one is if I exceed 100%, if I reach 100%, and so I need to create a new sensor here. You see, okay, you can set the sensor relative or absolute, relative between 0 and 1. I want to have 1 for the first control. And then I create with F4 a new control in the tank here. So I can wait until tank is full. Or question mark. This is one way to wait until no material is flowing into the tank. You can watch the attribute current inflow rate, and this is if this becomes 0, then there's no inflow anymore in this tank, and then I wait for 1 second, and then I close the entrance. And open the exit. It's like a valve that you open and close, and then it should start to emptying the tank. So now refilling. So exit lock still. Exit locked false. It was a long day. Okay, I want to close the entrance and open the exit. And to open the exit, I need to set exit locked false. F7. And now it should work. So you can see the coloring of the pipe is now changed to blue. And now the production is starting here on the injection molding machine. You can see step by step this tank becomes empty, and now we need a second sensor to move the next element, the next package of granules to the machine. And so I need a second sensor here. Maybe if we underrun 0.1, 10%, not let's see it underrun, then this control should be called. I triggered the transport from the source to the deportioner. with source.cont.move. And then I need to wait until the tank is empty. And then I need to lock the exit. And unlock the entrance. The transport is happening in parallel here. The worker goes to the source, takes the parts, move it to the deportioner, and during this time the tank will be empty, and it's difficult to do this without locking the exit or entrance, or you can also open and close the pipes. You easily come into an error message from plant simulation that you cannot move with different speeds, with different inflow rates and outflow rates into the tank, and so you need to lock the entrance and exit temporarily. Okay, let's have a look. So I fill up the tank and then I produce. So now it calls my second control. The worker is coming, holding again the machine with granules, and then the production starts again and again and again. And this is what you can do with the fluid library. You can model bulk materials that you can that you transport by packages, or you can also transport it by pipes. And at the end, you can produce some MUs and use these MUs to model all the following line or fluids. All kind of fluids. We can also model recipe-based production systems like a brewery. We will do this in the second webinar, where you have some recipe. Okay, you need to fill a tank, then you heat up the tank, and if the fluid is hot, then you pump it to another tank, and then you have some mixing and some processing in the second tank or second mixer. Then you empty the mixer to a tank again, and then the fluid is processed for a certain number of time, and then you fill up all this stuff into bottles or containers or what else. And so we can model also some very complex production systems in the pharmacy or in the food industry. I'm so sorry. Okay, the setting for this. Where should I start? Okay, the portion. Okay, settings. You also, I guess, don't see the materials table. Okay, start with the first model again. Okay, the settings we have to do. We have to fill the materials table. I guess you have seen this. But the attributes here in the fluid source, we have to set an outflow rate. Then the material, the source will create, and we have to set everywhere the materials table. And here the second fluid source for the concentrate. There's the outflow rate of 0.1, material selection, concentrate. And here it's only what the result should be, it's juice. And in the deportioner, we need to define the mu we want to create and the amount of fluid we use for this for 1 mu. I hope now you see the dialogues. Yes, and the second model we have, I create here granules as a mu. Materials table only contains only one material, this is granules. And in the deportioner, I need to define the amount material per mu is 50 liters. In the tank, I need to define an outflow rate of, for instance, 0.2 liter per second, and the complete volume of the tank. And the deportioner, again, we need to define the mu we want to create and the amount per mu. Okay, these are the settings. I activated here the transport importer, and that's it, I guess.
If you haven't been there yet, you can click on the link on the screen right now to get to the forums for plant simulation, because we do meet every 2 weeks. And we just encourage you to go to that link, and you'll see the animated GIF. It's showing you should follow the topic by clicking the button there. And then also go under the envelope icon and select every post there on that link. So that basically just means that you'll get a system email as soon as the recording is posted, as soon as we post new registration links for new sessions, then you'll get a system email immediately. Otherwise, you may be waiting on the marketing email. So just a lot of people prefer to follow the topic. And then on the left-hand side, you'll see that our last session for the year will be on Wednesday, December 10th. Stefan will be showing how to create a lift turn station from scratch. You can click the link there and register already if you know that topic is of interest to you. So happy New Year from then. We will definitely be back in about mid-January with some new topics. So all the more reason to follow the topic in the Plant Simulation virtual user group, so you'll be one of the first people to see the topics when we have them for January. So I don't know, Stefan, if you want to steal the screen back. Let's see. There's a question about units, but I'll answer the one about the community. So the person said they can see the URL and they wanted to know where they can get more examples.
And there you can find the virtual user group. Then you go to knowledge articles, and here you can find all the videos we have already recorded, all the webinars. Here's the list, and here you can find almost 40 different webinars, and the files for the webinars you can find directly in the forum. And more examples you can find at the start page of Plant Simulation. There you can find a small example collection, and many examples you can find there. What I lost again, how can different units be managed instead of liter per second when dealing with bulk materials? You can only change the weight. You can find this here in File, preferences, and then you get units, and there you can these are the units you can change, and you can change the mass here, and you can change it to pound or something, but you cannot change liters again, I guess. No. Liters, I don't. You cannot have. It's only the units of the data types: mass, currency, speed, acceleration, and length. We don't have a special data type for volume. And so I guess you don't find it here. So until now, there's no way to change the liter. Okay. More questions?
Well, I'll make one more announcement in case people are still thinking. If you may have already seen this slide before, if you've been with us for a while, but we do have additional learning through the Siemens Accelerator Academy. Those links you can also click on. So there's a Plant Simulation Associate Certificate, a micro-credential, and then just some other things around courses. So feel free to click through there. Other than that, there's a link to Stefan's profile in the community, and that is the link again for the forums, the community forums. So if you haven't answered the survey, it might still be on your screen. We appreciate you responding. And there's still a few minutes left for questions, 5 minutes left for any questions.
Yes, and I will post the model file in the forum when the video will be available. Then I will post in the same post the plant simulation file, and then you can download this file and play around with it.
I see some applause coming through. We definitely appreciate you, Stefan, as always, giving your time in your evening to be with us who are in other parts of the world during the day. See you all in 2 weeks, and see you in the forums. Bye-bye.
Bye-bye.